Theorem: let X be a metric space, then any intersection of closed sets in the metric space X is closed. Similarly, any finite union of closed sets is also closed. These properties are in fact dual of the properties satisfied by open sets in metric spaces. Let us prove this property 1. Consider a collection of closed subsets of our metric space. First, let us assume that Fi is a collection of closed subsets of our metric space, capital X. If we let capital F as the intersection of these sets Fi, then we need to prove that the intersection capital F is closed. So it is enough to show that its complement F dash is open. Consider the complement F dash, that is the complement of intersection Fi, and by De Morgan's law this is equal to union of complements, and we know that each of the sets involved in this union, namely Fi dash, are all open sets, since each Fi is closed. So this union Fi dash is in fact the union of open sets, and we know that the union of open sets is always open. So the union over I Fi dash will be open, or we can say that F dash is open, and this will imply that its complement F is closed as required. Hence we can conclude that any intersection of closed sets is also closed. The proof of second property is similar. Here we can assume that Fi, where I varies from 1 to n, are closed sets in our metric space. Then consider their union, say G equal to in union I varying from 1 to n Fi. We will need to show that G is closed. So it is enough to show that its complement that is G dash is open. Let us consider G dash, which is in fact the complement of the finite union. Complement of union I varying from 1 to n Fi. And using De Morgan's law, we can write this as the intersection over I varying from 1 to n of complements of each of these sets. So this will be equal to intersection over I varying from 1 to n Fi dash. Here each Fi dash is open since Fi is closed. Therefore, union I varying from 1 to n Fi dash being a finite intersection of open sets is open. That is, our set G dash is open, and this will imply that G is closed. So we have proved that finite union of closed sets is also closed in the metric space X. This completes our proof.